I lost internet connection again. I switched here my modems. Let's see if it works better now. Okay, I have, like I mentioned before, I have two modems from two different internet companies. When one starts misbehaving, I just switch to the other one. Let's hope that we do not have any more problems with the internet connection. We are recording. Let me share the screen. Here you go. If you missed anything, okay, this is the one that this is the one that obeys the ohmic. This is the ohmic. This is the graph. Here you go. Here's the graph for the ohmic element. This is the graph. This is the graph for the non-ohmic element. Here you go, like that. Now I'm gonna plot for you V1 versus I. This is the one that you're already familiar with. I'm gonna insert the graph. Here you go. We get exactly a straight line. Okay. And we are going to right click, add trend line, and whatever slope you see right in here is the strange. Let's try it again. Okay. The slope of this equation is going to be the resistance of my resistor. Let's see. It says that 82.5, right? Let's see what we have here. It says that 81.3. So very close. Not bad, right? Now, what's going to be a little bit surprising for you is whenever we plot VB against I. Insert. That's like you can see, this is not a straight line. It's more like a hyperbolic third order polynomial. Okay. Click, right click, add trend line. But now you are going to, it's not going to be a linear, it's going to be a polynomial fit. And it's going to be a polynomial fit of order 3. Okay? Excels allow you to fit the equation for different functions. For this specific case, it's going to be a polynomial of order 3 and display equation chart, display R-square value on chart. Here you go. And now you have an idea how a non-ohmic element behaves in a circuit. I will bold face it, and I'm going to change to 20 so you can see better the equation. Okay, so that's the most important part of the spreadsheet. Okay, you're going to put how many data points you have here. That's going to be 10 because we have 10 measurements. The regression equation, you're going to copy exactly what you have here. Let's see if we can paste. And paste, yeah. 650 x to the cube. The x in reality is the I, right? R square is 9971, 0.9971. We need to have our break, right? And then you get the CL, mean and maximum, from the table. Okay. So we're gonna have our 15-minute break, and when we return, I'm gonna walk you through the significant figures of this whole table, okay? So you can get a better grade for the significant figures, and let's not forget also about the units, right? V for units for V1 and VB and V total is volts, right? Even V1 plus VB, and the unit for RB is the resistance. The unit for the resistance. This guy too, the unit for the resistance should be a ohm. Okay, and it's 12:05. Let's have our break. And any questions? I see you. If you don't have a break from 12:05 p.m. to 12:20 p.m. And when we return, I'm going to help you out with the significant figures, since I have been noticing that you're having difficulties with that, okay? See you in 15 minutes. I am back here. Okay, so now you have the two graphs, right? You already, I'm hoping you all got the graphs there. Let me go through the class. Whoa. Today is the 13th. Oh, graph 1 and 2. Oni, did you plot the graph 1? Two graphs, right? Is Oni there? Oh, wow.
Yes, I'm here.
Okay, did you plot graph number 1?
Yes, I I plotted graph number 1.
Okay, what about graph number 2?
No, I haven't plotted graph number 2 yet. I'm about to do it right now. I'm about to do it in a few minutes.
Okay.
But yeah.
Oh boy. Let me get something here. Looks like it's cold here where I am. When you do the graphs, don't forget also to to make the graph look nice, right? The first thing that you want to do is to change the font size of the axis along the y direction. Let's say 14 font size. 14 font size. We also want to put it in boldface to make it easier to read it. I think we need a slightly. Oh boy, here you go. Yeah, it's slightly larger size, 16. And you also want to change, for this axis, you want to change the font instead of scientific format. You want to put it, let's see here. You want to put it in the field. Oh, okay, go right in here. Axis options. Number. Okay, axis options. And number, you want to change from scientific to numeric. Okay. I think that's too small. Let me change the size a little bit again. Maybe 18. Let's try 18 here. Yeah, I think it's okay this way. Along the X direction, you might also do the same. You want to change to numeric format, two decimal places, and the size. Size is 18, right? See here. Font size. Let's use 18, and let's not forget to put bold-faced. Yeah. What else do we have to do? We have to label the axis. We don't need to put a chart title. You gotta display the equation prominently there. Notice that we have a big blank space here. So we can adjust the x-axis so I don't take out points from you whenever I'm correcting the lab report. Let's see what's the value here of this guy. 0.11. 0.11. We can, shorten it to 0.12. 0.12 and 0.12, and we adjust major units to 0.02. 0.02 seems too much. Let us try 0.04. Okay, can even be 0.03. Let's see if it's 0.03. Yeah, 0.03 works as well. Okay, and now we decrease, we optimize the graph space so you do not have this big blank area, right? What else do we have to do? Well, now we have chart design. Click the chart, right? Click the chart and watch what happened there. Chart design. I'm going to unclick the chart, and that option for chart design disappear, right? So we want to put the labels in the axis. Add chart element. We must have chart design here to add the chart element. Add axis title. Primary horizontal. Primary vertical. And we are going also to use a larger font size. In this case, I want to use font size 20. And we are going to read boldface. The x-axis is going to be the current. Write down I, between parentheses, the unit for ampere. And here for the y-axis, is, let's see, this one here is V1, right? So you write that down, V1. V1 between parentheses, V is going to be font size 20, bold-faced. And let's not forget to put this subscript here for the V1. So everything looks nice, right? Italics. I'm gonna put the V italics here. Yeah, the current shoe, right? Italics. The unit ampere in italics. Which size, font size is this one? 24. Yeah, let's put 24. 20 still appears very small for me. 24. So that's how our graph should look like. Now let's take a look at this graph here. We repeat what we did there, right? In this case, the maximum voltage is going to be what? It's going to be 1 volt only, 1.01 volts. So we can, let's try minus 1.2, okay, and plus 1.2. Yeah, it still didn't work well. Let's try 1.1. We still have a big space. Here you go. And if we put 1.1, we have major axis. Let's put 0.1. Let's see what we get. No, it's too close, right? 0.1 is too close. Okay, so let's put 1.2, and then a space of 0.2 here. And now looks better. And we want to change the size, font. Not just want to change the size, but the style as well. Font size is going to be 20, boldface. And that's how it should look like. Let me move my regression equation elsewhere. Yeah, I cannot move it anywhere else. Yeah. Yeah, that's the best I can do. I'm going to change the numeric format from scientific to number. And we should have, in this case, just 1 decimal place is enough. I think it's a little bit too tight here. So instead of, too close to each other. So instead of 0.2, let's make 0.3. Okay? Let's make it 0.3. 369, 1.2. Now we gotta do the same thing right in here. The first thing you want to do is the font size, 20, boldface. Good. You want to change the format from scientific to numeric. And in this case, we want 2 decimal. Let's try 2 decimal places. So let's see if we need, 2 decimal places is a good measure. But you don't want to go until 0.15 because you have too much of a blank space here. Let's see which value we should go to. The largest current value is going to be 0.11. So we can go to 0.12. Okay, instead of 0.15, like he assumed on default, we write down 0.12. And now we are optimizing the space in the graph. What else do we want to do? Instead of 0.05, let's make it 0.03. Yeah, or maybe even 0.04. Here you go. Okay, 0.04 is better, right? We have a little bit of space here, but we cannot do much about it. So that would be the best I could do for this graph. Okay. That's 12:34. We have another 15 minutes. What I want to cover with you, it's the significant figures, right? The significant figures of those cells that you see here can be obtained from that. Significant figures of those cells that you see right in here can be obtained from that document that I distribute to you all. Let's take a look at the document. It is P07 sig fig. Let's see, where is that? P07 sig fig. P07, maybe it's in the lab. Yeah, right in here. It's in Canvas. You can download it. And here you go. Okay, so here you go. The first significant figure that we have, the first table of significant figures that we have is for the resistance. And it's also my first table in the spreadsheet. This one here. We start with the first table, the values of the resistance. The first resistance that you see here is 81.3, right? So you look at this table, where 81.3 falls in this table. It falls in this line right in here, right? And this table indicates that the significant figure for those values between 10 and 99.99 is 4. We have, consequently, we must have a second decimal place there in the format, in the numeric format cell, right? Number, 2 decimal places, and now we have 4 significant figures displayed. 1, 2, 3, 4. 0 to the right is a significant figure. We do the same for the resistance of the bulb, and the resistance of the bulb in this case we measured when the light bulb was disconnected from the circuit. We call it unloaded configuration. We call it unloaded configuration. The numeric value of this resistance is 1.69. 1.69 falls within this range here, 1 through 0.99. And this table tells us that the number of significant figures we must have is 3. Okay, so here you go. We have 3 significant figures. 1, 2, 3, 2 decimal places, 3 significant figures. Let's see, right click, format cell, number, 2 decimal places, 3 significant figures. That's how you adjust. And now we can work the rest, right? V sub. I'm going to do just the first one right in here. V sub. The V sub should be in a different table. V sub should be in this table here, in the second table. V sub power supply. Anything between 10 and 20 is 4 significant figures. What do we have here? In my case, I have 10 exactly. 10 significant 10 numeric value 10 must have 4 significant figures. So we have to format it in numeric format with 2 decimal places for significant figures. Okay? And you do the same with the rest. The rest, wouldn't be much different, because here you go. Between 1 and 99 should be 3 significant figures. To get 3 significant figures, we have to have 2 decimal places. Okay, format cell, numeric value, 2 decimal places. Here you go. 3, 3, 3, 3, 3, 3, 3, 3, 4 significant figures. All of them has 2 decimal places. Let's go for the voltage. Voltage as measured by the DMM. Okay, here you go. Those 3 voltages right in here. This voltage is 904. This voltage is 1. This voltage is 997. Okay, so it should fall Yeah, let's start with this one. 9, okay, so it should be, yeah, it should be this for the first column, should be this row here in the table, voltage DMM, see that? Voltage DMM. Between 2 and right click. We're going to look at the I later on, okay? Voltage 1, right click, format cell, numeric format. Let's try 3 decimal places for now. Let's see if we get it. Should be 4. Yeah, we have four significant figures for 3 decimal places. Okay, 4, 4, 4, 4, 4. And they are all between 2 and 9.999. Good. What about VB? Let's see, VB. The largest value is 1.01. The lowest value is 0.0597. Okay, so where does it lie? It lies right in here in this row. No, right here. No, wait a minute. The largest is 1.01. Okay, let's do for 1.01 first. 1.01 falls exactly here in this row. We must have 5 significant figures or 4 decimal places. Right click, format cell, change it to numeric. 4 decimal places is 5 significant figures, and that's what we get. 1, 2, 3, 4. The same thing goes for this guy, right? Format, number, 1, 2, 3, 4. You go. And everything else in between should be between 0.2. Let's see here. 0.2 and okay, 0.2 is those two values here. Those two values is between 0.2 and 0.999, right? Here you go. As well as those two values right in here. Should be 5 significant figures or 5 significant figures or 5 decimal places. Let's see here. Format cell, numeric, 1, 2, 3, 4, 5 decimal places, which give us 5 significant figures. What about the rest? This one here, 0.1, 0.104. 0.104 falls within this row. 5 significant figures as well. Okay, those two is supposed to be 5 significant figures or 5 decimal places. You go. Number 1, 2, 3, 4, 5. That's how you're supposed to display it. The other one is 0.059, 0.0597. 0.0597 is between those two values. And you must display 4 significant figures. 4 significant figures should be how many decimal places? Should be 5 decimal places. Okay, format cell, numeric, 1, 2, 3, 4, 5. Let's see if we got it. 4 significant figures. Yeah, we got 4 significant figures. Did you get the idea? That would be for the voltage measured by the DMM. V total 2 is the voltage measured by the DMM. This column that you see here, you use the other table. They use the table for the current. Oh, for the current. Let's see. This current here is 0.11. 0.11 is within those two values. Okay, and within those two values, the number of significant figures is 5. 5 significant figures, 5 decimal places. 5 significant figures, 5 decimal places. number. Here you go. Here, 0.0888, right? 0.0888 is within this range that you see here for significant figures. For this specific measurement, for this specific range of measurements, right, should be all of them. For significant figures should be 5 decimal places in the numeric format. 1, 2, 3, 4, 5. Let's see if we got it right. 1, 2, yeah, 4 decimal place for significant figures. That's so I did the for everyone, right? And now here, okay, 4 more minutes to go. Huh? We use the rule of summation, V1 plus VB. Okay, we do not use the table. We use the rule of summation. The rule of summation, you preserve the least number of decimal places. This measurement has 3 decimal places. This other measurement has 4 decimal places. So you have to display it with the summation with 3 decimal places. Format cell. Number 1, 2, 3. Here you go. 3 decimal places, 4 decimal places, right? Display with 3. Here, 2, 3. This one has 5. 3, 5, 3, 5, 3, 5, 3, 5, right? So everything else should be 3 decimal places. Format cell. Number 1, 2, 3. And now we have the right number of significant figures there. Don't forget, in order to get the number of significant figures here, you must have the number of significant figures right here. What about here? Is the least number of significant figures, right? Between VB and VI. VB has for 5, I has 5. Here is 4, here is 5. Okay, for the first one is 5 significant figures. 5 significant figures should be 4 decimal places in the numeric format. This one too. Okay. That's okay. So VB, right? VB over I. 1, 2, 3, 4, 5. Okay. Here's 4 and 5. 4 and 5. 4 and 5. 4 and 4. Okay. 4 and 4. 4 and 5. 4 and 5. And also we must display it with 4 significant figures. Format cell. 4 significant figures should be 3 decimal places. So I did all the significant figures here for you, right? We have 1 more minute to go. Any questions before we? So I guess. Okay, I guess we can stop here. We have just 1 more minute to go. We did the graphs, and don't forget the units, right? Units here, units here. And that's all. 1, 2, 3, 4, 5, 6 units that you have to fill up.
Professor, can you show the CL again?
CL, yes. Let me just, let's go for the CL, right? We gotta write down the R square here first. We have 10 measurements. Format cell number. Here you go. Format cell. I gotta put it 4 decimal places, but I want numeric format. Here you go. 997. Why did I get? Why do I have 9999 here? Oh yeah, that's because I'm looking at the wrong graph. Okay, so first you have to write down the number of data points and the R square, right? To find the CL. Okay, with those two values, we go to this table of CL. Where is my table of CL? Confidence level. Let's see, student roster. Confidence level. Where's my confidence level table? I'll have to download it from. Okay, let's download it from Canvas. Okay, Canvas, LAHC. You know, they used to have a link for Canvas here, right? But they took it out for some reason. So we have to go through the SIS portal. Canvas. It was so convenient to have that Canvas link there, in that drop-down menu. And LACCD. We are going to go to the Physics 7 390 section. And we got to go to modules. Confidence level, right in here. Let me download this document. And now I have my table here, right? So let's put the spreadsheet and the confidence level side by side, each other. Okay, let me. Okay, so here you go. We have n equal to 10. Okay, so by the way, let me stop recording since we are in my office hours now. No, it's not what I want. Let's see, someone asked the question here. Can you show how to change scientific to numbers for the graph? Okay. Okay, Susan, I already did that. Can I do that? Do you want me to do that again, Susan? No? Okay, good. So let's see here. What do I want to do? I want to stop recording. Pause.